Hi everybody, I am Dr. T. Antony Santosh, Assistant Professor of Chemistry, St.Joseph's College of Arts and Science, Cuddalore. I would like to teach a topic for second BSc Chemistry students. The subject code is SANDOSH-CH305A, Inorganic Chemistry 2. In the first unit, we have solution and types of solvents. Now let us discuss what is solution. A solution in chemistry is a type of homogeneous mixture of two or more chemical substances where a minor component is uniformly distributed within the major component. When the solvent is water, we used the term aqueous solution. If the solvent is not water, that is non-aqueous solution. Okay, the minor component is usually called solute. The major component is usually called solvent. This is one way to define solution. So here we have a diagram which explains what is a solution. So here we have a solute which is initially a solid, a solvent which is a liquid. Here it is mentioned as water. When we mix the solute plus solvent, we are getting a solution. So solution, what we are getting here is a uniform solution. The solute gets dissolved in the solvent. Okay, so in different manner we can define the solution. So a solvent is which one dissolves the solute, and a solute is the one which gets dissolved. Clear? So solute gets dissolved and the solvent dissolves the solute. So the resultant content is the solution. Here we have solution in a different characteristics. Solution have two components. One is solvent and the other is solute. That is one of the characteristics. What is solvent here mentioned? The component that dissolves the other component is called the solvent. What is solute then? The component that is or dissolved in the solvent is or are called solutes. Generally, solvent is present in major proportion compared to the solute. The amount of solute is lesser than the solvent. The solute and the solvent can be in any state of matter, that is solid, liquid or gas. So that should be noted. We could see some examples in the next slides. Solutions that are in the liquid state consists of a solid, liquid or gas dissolved in a liquid solvent. Alloys and air are examples of solid and gaseous solutions respectively. So in the next slide we could see what are all the properties that should be possessed by a solution. A solution is a homogeneous mixture. So it should not be a heterogeneous. What is homogeneous? Uniform throughout. A solution should be a uniform mixture of solute and solvent. And second point, its particles are too tiny and have a diameter of less than 1 nanometer. Its particles are too tiny. So here we could see the preparation of solution is made up of some solid or liquid or gas material of solutes. So it just uniformly dissolved in the solvent. So here the size is given. The solute particle should have a diameter of less than 1 nanometer. Next point is the particles are not visible to naked eyes. Of course, if the size is less than 1 nanometer, the diameter is 1 nanometer less than 1 nanometer, means we cannot see by our naked eyes. Next point, particles don't scatter a beam of light passing through it, and hence the path of the light is not visible. Yes, the path of the light is not visible because the particles present in a solution don't scatter a beam of light. And the next point is solutes are inseparable from the mixture and do not sediment. So there will be no formation of sediment or precipitation like reactions. It is a physical change. The dissolution is a physical change, not a chemical reaction. So the solution is a stable one. The components of a mixture cannot be separated using filtration. So what we have dissolved in a solution, that is solute, cannot be separated using filtration. Using filtration we cannot separate it. So these are the important properties of a solution. Let us move to see some of the examples of solutions. So here once again we have a different type of definition. What we have already seen, the parts of a solution. A solute is the part of a solution that is being dissolved, usually the lesser amount. And the solvent, the part of a solution that dissolves the solute, usually the greater amount. So solute plus solvent gives solution. So here we have some examples identifying the components of solution. So if the solution air in balloon, we have oxygen as a solute and nitrogen as a solvent. That is the first example here. But why it is so? Because solvent nitrogen is present in majority, so oxygen present in minor amount. So it is called, oxygen is termed as the solute in the solution, and nitrogen, because of its major amount, it is called the solvent. Next, ammonia in water. Ammonia as a solute and solvent water. We have, of course, ammonia gas dissolved in water, so that NH3 is a solute and H2O as a solvent. Next, we have H2O as a solute in the isopropyl alcohol of solvent. That is different example. Next, ethyl alcohol in solute and water as a solvent. The proportion, the amount makes it. Next, tincture of iodine present as a solute in the solvent of alcohol. Iodine in alcohol is one of the example, medicinal example. Next, seawater. Salt is dissolved in water. In seawater, we know there are different kinds of salts are present in it. So the solute is the salt and the solvent is H2O. So these are different kinds of examples. Next, we could see a flow chart. So already we have seen the solvent and solute mixed together to prepare a solution. And according to the topic, we are seeing now a flow chart for solvent. So the solvent has two types initially, polar solvent and non-polar solvents. And the polar solvents are further categorized into protic and aprotic. So this is one important flow chart which classifies solvents into polar and non-polar, and again polar into protic and aprotic. So let us discuss the different categories in our second video. Thank you very much.